All right, algebraites, let's take a gander. Today we're going to continue to solve natural log and exponential equations. And today we're going to focus on a concept called natural log, which is still a log and still exponential equations. All right, in example number 1, you deposit $500 in an account and you just let it sit there, okay? That compounds interest continuously at a rate of 4.5%. That is, every year you get 4.5%, but it's actually a little bit more. Now, using this formula, A equals PE to the RT, where A is the amount you have, PERT, after T years at a rate of R, P is the principal, your initial amount. So when will you have $750? So after how many years? When will you have $1,000? And when will you have $1,500? So the first thing to think is, when will I have $750? So again, notice what's happening. You put in $500 and you just let it sit. And every couple months or every month they put in a little bit more money because of interest. Okay, so how do we handle that? It's simply just plugging things in. So let's go ahead and I'm going to start with the super formula. A equals P e to the RT. A equals PERT. A means the amount of money you have after certain many years. So I'm going to plug in. Notice the initial, I don't know what A is. I'm looking for, actually I do know what A is, excuse me. What is A? What's the amount that I want? It's $750. All right, so I want to have $750. My initial amount is $500, so that's P for principal. E is a number. We'll get to it in a minute, but your calculator has it. It's 2.71. What's my rate? Well, they told us what my rate is. It's this, but as a decimal is 0.045. Remember, you move the decimal over 2. So I'm going to put 0.045 there as an exponent. And notice I don't know what t is because I'm looking for the number of years it will take for me to earn an extra $250. Oh, so what are we going to do first? Notice what I need to get by itself. I need to get E by itself, right? Well, excuse me. Once I get E by itself, I can undo E by doing natural log. So notice the T is going to get by itself. So I have to get rid of the 500. So what do we divide both sides by? 500. So when you divide by 500, this drops out to be a 1. And over here, I'm going to get a decimal. So this here gives me 1.5 equals E to the 0.045 t. Now I'm in a position to rewrite it. Rewrite it. Remember what I told you before, that the log of E we called the natural log, ln. So when the base is 2.71, we just say ln. So how do I write it? Well, the natural log of 1.5 is equal to the exponent there, 0.045 t. So now what we're going to do is take the natural log of 1.5 in our calculator, and we get 0.4055 is approximately equal to 0.045 t. Now how do I get t by itself? I divide both sides by 0.045. So just in your calculator, do that. And in the end, t is going to be approximately 9.01. 9.01 what? Let's think about it. We put this money in a bank. We let it sit, so it's 9.0. How long is it going to be? Days, weeks, months, years, decades? Good. This is years. It's going to take you about 9 years just to earn, to get to $750. What about 1,000? What about 1,000? Now, maybe your instinct says, well, I earned 250 in 9 years, so maybe I need to double that, so it's 18 years before I get to double the other one. However, that's actually not going to be the case. So in this case, my amount is going to be 1,000. So A equals My principal is still 500. Then I have e to the r, and r is still the same, 0.45, and t is still t for time.
What do you plug in?
So now we divide by 500.
Yeah, I did that, but now what do I plug in?
To 2 equals e to the 0.045 t. Now when I rewrite it, I say natural log of 2 is equal to 0.045 t. Now with your calculator, you plug in a 2 and hit the natural log button. 0.6931 is approximately equal to 0.045 t.
What is t?
Both sides by 0.045, just 0.045. I'm going to get approximately 15 years, 15 point something years. Notice it's not double. Double of the previous was 9 times 2 is 18. So it's actually a few years less than that.
Have you ever been to Compton?
All right, so we're going to continue on that.
He said he's drove.
Okay, so let's take a gander at this one. We're going to solve the exponential equation. We're going to round each answer to the nearest hundredth. That's 2 decimal places. So what you need to remember, and we've mentioned this before, but we'll point it out, that whenever you have log with a base e, we call that the natural log, ln. So A, we can think of it as rewriting using the natural log, or exponentializing both sides, or taking the log of both sides. If I take the natural log of both sides, like this, that's the same as rewriting. Why? Because here, the natural log and the e are inverses, so they drop each other out. And on this side, I get the natural log of 9. Yep. Now all we do is plug this into our calculator, so please pull out your handy-dandy calculator and find the ln button. We get approximately 2.197. Continuing on example B, we want to undo and get rid of the e at some point because I want the exponent to be by itself. I'm solving for x. So the first thing I'm going to do is subtract 4 from both sides. In doing that, I get e to the 5 minus 3x. All that equals 2. Now, again, there are 2 ways to consider this. Number 1, I could write ln in front of both terms so that the e and the ln drop each other out. Or I can rewrite it. I can say natural log of 2 is equal to that. So natural log of 2 is equal to 5 minus 3x.
How do you do the other way too? How do you write the other way?
The other way would be like this, where I put a big ln in front of each. And what happens is that the ln and the e drop out, which brings me just that, which is what I wrote on the right side there.
Okay.
And natural log of 2 is there. Now, we pull out our calculators and evaluate natural log of 2. So go ahead and do that. And then we get 0.693. Now, I'm not going to clear that out of my calculator. Because notice with my calculator, there are 2 other things I'm going to do. I'm just going to subtract 5, and divide by a negative 3. You don't even have to write all that. Just with your calculator, without clearing it, subtract 5 and divide by negative 3. And in the end, when I subtract 5 and divide by 3, and then take the opposite, I get 1.44. And now let's take a gander at example number 3, part A. So this part's a review. Remember that this has a base of 10, so I can rewrite or exponentialize both sides. If I rewrite this, I have a base of 10 of to the power of 1 all equals this amount there. So equals 2x plus 1. And now from here we subtract 1 to get 9 equals 2x. And since we're rounding to the nearest hundredths, I'm just going to go ahead and divide by 2. And in its place, I'm going to write 4.5. All right, and the last one over here. before I can get rid of the natural log, I need to make sure this is by itself. So I'm going to add 2 to both sides, like so. So the natural log of x plus 3 is going to be 10. And now I can exponentialize or rewrite in the terms of e. What happens here? Those drop out, and I end up with simply the x plus 3. And on this side, I get a rather large number, e to the 10th power. 22,026.47. And now I have to subtract 3 from both sides. So I'm not going to even clear my calculator. I'm just going to subtract 3 from both sides. So x is 22,023.47. And there we have it. Now practice the other side and check answers online.